Hello, in this lecture we find out the area of the green shape using two different methods. In the drawing we have three identical squares. The area of this side of this square is equal to 2. Therefore all the other lengths of the other squares must be also equal to 2. So are identicals. So, in addition, we have in the drawing this right triangle. So the green shape, this green right triangle. So our text is to find out the area of this green right triangle. So first of all, I will clarify two concepts. The first concept is the Cartesian system, and the second concept is the slope of a straight line. So what is the Cartesian system? We know that the plane has two dimensions, the horizontal dimension and the vertical dimension. In the Cartesian system, the horizontal dimension is presented by the x-axis. This is the x-axis, and the vertical dimension is represented by the y-axis. And the intersection point between the two axes, that is to say the x-axis and the y-axis, is this point, and this intersection point between the two axes, this point is defined as origin. That is to say, it is the starting point of both axes, the x-axis and the y-axis. So we define the origin. This point is point O, and again, the origin is the starting point of both axes, and therefore the coordinate x of the origin point is equal to 0, and the coordinate y of the origin point, point O, is also defined as 0. So both coordinates of this origin point, that is point O, are equal to 0. Every point in the plane is represented by two numbers. The first number represents the horizontal distance. For example, this is point A, and the coordinate x of point A is the horizontal distance of point A from the origin point O. And the horizontal distance is this distance. This distance equals to minus 3. Minus 0 is minus 3. So the first coordinate of point A is minus 3. And the second number represents the vertical distance of the point from the origin. So this is point A. The vertical distance of point A from the point O, the origin, is this distance. This distance equals to minus 1, minus 0 is minus 1. So the second number, that is coordinate y of point A, is minus 3. So in total, point A has two numbers. The first coordinate of point A is x coordinate is equal to minus 3, and the second coordinate of point A, and that is the y coordinate, is equal to minus 1. Again, the horizontal distance of point A from the origin is minus 3 minus 0, that is minus 3. So the first coordinate equals to minus 3. And the second coordinate, that's the y coordinate, is the vertical distance of point A from point O. The vertical distance is this distance. That is to say, it is minus 1 minus 0 is minus 1. So point A is represented by two numbers, that is minus 3 and minus 1. Okay. And the second concept is the slope of a straight line. The slope of a straight line measures the steepness, the sharpness, the inclination, and the direction of a straight line. Repeat again. The slope of a straight line measures the steepness, the sharpness, the inclination, and the direction of the straight line in relation to the positive x-axis. And it is defined, the slope of the straight line defined as the ratio of the vertical change to horizontal change. So the slope m of any straight line equals to the ratio between the vertical change, that is y2 minus y1, over the ratio of the horizontal change, that is x2 minus x1. So in the drawing we have two straight lines, the red straight line and the blue straight line. The slope of this blue straight line is 3, and the slope of this red line is 1/3. And because of the fact that the blue line has slope 3 that is greater than 1/3, its steepness is greater than the steepness of this red line. You see it from the drawing. Okay. And if the slope of a straight line is a positive slope, then the straight line goes up from the left side to the right side. Again, the straight line rises from the left side to the right side. Likewise, if the slope of the straight line is a negative slope, then the straight line goes down from the left side to the right side. That is to say, it falls from the left side to the right side. And finally, if the slope of a straight line is 0, then the straight line is parallel to the x-axis. You see it? This straight line is parallel to the x-axis. And the slope of a straight line is also defined as the tangent of the angle that the straight line makes with the positive x-axis. This is the positive x-axis, and the angle that this straight line creates with the positive x-axis is theta. And therefore the slope of this straight line, this blue straight line, m equals to tangent theta. Okay, the slope of a straight line equals to the angle, the tangent of the angle that the straight line makes with the positive x-axis. In this case it is theta, and therefore the slope of this blue straight line, m, equals to tangent theta. We know that the diagonals of a square bisect its angles. This is a square, and this diagonal bisects this angle. All the angles of all the squares are right angles. So this right angle has been bisected into two halves. The first half is 45 degrees. And the second half must be also equal to 45 degrees, of course. In the next step, we create the Cartesian system in our drawing. So this straight line will be defined as x-axis. This is the positive side of x-axis. This is the negative side of x-axis. Likewise, we define this straight line as y-axis. This part is a positive side of y-axis, and here this is the negative side of y-axis. The intersection point between x-axis and y-axis is this point. We define this point as point O. Point O is the origin of this Cartesian system. That is to say, it is the starting point of both those two axes. Therefore, the coordinate x must be equal to 0. And the coordinate y must be also equal to 0. In the next step, we define this point as point A. What are the coordinates of point A? The x coordinate must be equal to, here we have, this is the positive side of x-axis, and this is the negative side of x-axis. From point O, that is 0, point O, x equals to 0, we'll move left to the negative x-axis, 2 steps, plus 2 steps, plus 2 steps, in total it is 6 steps. And therefore, this is the negative side of x-axis, and therefore the coordinate x of point A must be equal to minus 6. Likewise, what is the coordinate y of this point A? We know that this side equals to 2, so the coordinate y of point A is also 2. So in total, the coordinates of point A are minus 6, that is the x coordinate, and 2, that is the y coordinate. Likewise, we define this point as point B. We don't know the coordinates of point B, so we define the x coordinate of point B as x1, and the y coordinate of point B is y1. In the next step, we will find out the slope of this straight line BO. Repeat again, we find out the slope of this straight line BO. According to the definition of a slope, the slope of a straight line is the tangent of the slope, the angle creates with the positive x-axis. The tangent of the angle that this straight line creates with the positive x-axis is this angle. This angle equals in total to 45 degrees plus 90 degrees. The two axes, that is to say axis x is perpendicular to axis y, therefore this is a right angle. So the angle that this straight line BO creates with the positive x-axis, it is this angle. This angle in total equals to 45 degrees plus 90 degrees, it is 135 degrees. And the slope of this straight line BO, the slope M of the straight line BO equals to the tangent of the angle that this straight line creates with positive x-axis. The angle is 135 degrees, so tangent 135 degrees is equal to the slope of this straight line BO. And know that tangent 135 degrees equals to minus 1. Again, so the slope of the straight line BO, the slope M equals to minus 1. You can see that this straight line goes down from point B towards the right side. Why? Because of the fact that the slope of this straight line is negative, therefore it goes down, it falls from point B to the right side. Because of the fact that the slope is negative. So in the next step, we find out the equation of this straight line BO. Straight line BO passes through point O, and you know that the slope of this straight line BO equals to minus 1. M equals to minus 1. And the general formula of any straight line is as follows. Y minus y1 equals to M. M is the slope of the straight line times x minus x1. x1 and y1 are the known coordinates of the point that is located on the straight line itself. This is point O that is definitely located on the straight line BO. So x1, the x coordinate equals to 0, and the y coordinate y1 also equals to 0. So it is known. The slope of this straight line BO is minus 1, so M equals to minus 1. Repeat again, that point O is located on this straight line BO. Therefore, x1, the x coordinate of point O is 0. Likewise, the y coordinate of this point O, that is the origin, is also equals to 0. So if you have all the data that is needed in order to find out the equation of this straight line BO. According to this equation, that is the equation of any straight line, the equation of the straight line BO will be equal to y minus y1. y1 is 0, so it is y minus 0 equals to m. M is minus 1 times x minus x1. x1 is also 0, so it is x minus 0. So in total, we found out that the equation of this straight line BO is equal to y minus 0 and y minus 0 equals to minus 1 times x minus 0. So y minus 0 is y, and is equals to minus x times 1 is minus x, and here x minus 0 is 0, so we left only with x, so it is y equals to minus 1 times x. So y equals to minus 1 times x is minus x. So in other words, note that the equation of this straight line below is y equals to minus x. In the next step, we find out the slope of this straight line AO. Repeat again, we find out the slope of this straight line AO. Already presented to you a couple of minutes ago that the slope of any straight line equals to y2 minus y1 over x2 minus x1. So we have the straight line AO. This is the straight line AO. We know that point A, the coordinates of point A are minus 6 and 2. Likewise, the coordinate of this point O, that is the origin, are 0 and 0. We define the x coordinate as x2. We define the y coordinate of point A as y2. Read again, x2 equals to minus 6 and y2 equals to 2. Likewise, at this point O, that is the origin, we define the x coordinate that is 0 as x1, and the y coordinate of this point O is y1. So x1 equals to 0, and y1 also equals to 0. So the only thing that is left to do is just to put the data of this straight line AO inside this general formula for a slope, and in this way we find out the slope of this straight line AO. We do it now and get that m, the slope of this straight line AO, equals to y2 minus y1. y2 is 2, minus y1 is 0 over x2. x2 is minus 6, x2 is minus 6, minus x1, that is 0. So the numerator we have 2 minus 0 is 2, over minus 6 minus 0 is minus 6. We divide both the numerator and the numerator of this number by 2, so 2 over 2 is 1, and minus 6 over 2 is minus 3. So in total, I should find out that the slope of this straight line AO, the slope of this straight line AO equals to minus third. M equals to minus third. The slope of this straight line AO equals to minus third. You can see that the straight line AO falls down from the left side to the right side. Okay? Why? Because of the fact that the slope of this straight line AO is a negative slope. Therefore, it falls from the left side to the right side. Okay. In the next step, I present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule 12. According to Rule 12, if two lines intersect with each other at 90 degrees, that is to say, if two lines are perpendicular to each other, exactly like in this drawing, they make 90 degrees with each other. And we know that the slope of the first line is m1, the slope of this side line is m1, and the slope of the second line is m2. The slope of this line is m2. Then, according to Rule 12, the product of their slopes is equal to minus 1. That is to say, m1 times m2 equals to minus 1. So according to this Rule 12, if two straight lines are perpendicular to each other, that is to say, at their intersection point they create 90 degrees, like in this drawing, then the product of their slopes is equal to negative 1. So we can definitely implement Rule 12 in our drawing. Why? Because of the fact that in our drawing, the side line AB the side line AB is perpendicular to the side line AO. So those two straight lines are perpendicular to each other. And therefore, according to Rule 12, the product of their slopes must be equal to negative 1. The product of the slope of this side line AO is 1/3. We don't know what is the slope of this side line AB. So we define the slope of this side line AB is m2. And according to Rule 12, the product of their slopes must be equal to negative 1. That is to say, m2 times 1/3 equals to minus 1. So I write it down. So according to Rule 12, because of the fact that the side line AB is perpendicular to the side line AO, the products of their slopes must be equal to minus 1. That is to say, m2 times minus 1/3 equals to minus 1. m2 times minus 1/3 equals to minus 1, negative 1, according to Rule 12. Here we will multiply this equation by minus 1, and you get that minus times minus is plus, so in this side of the equation we will have m2 over 3. Likewise, on the other side of the equation we have minus 1 times minus 1, that is plus 1. So in total we should find out that m2 over 3 equals to 1. Here we will multiply this equation by 3 and get that m2 equals to 3. That is to say, the slope of this straight line AB, m2 equals to 3. And because of the fact that the slope of this straight line AB is a positive slope, you can see that it rises from the left side to the right side. Exactly as I explained a couple of minutes ago. So we know that point A is definitely located on the straight line AB. So whenever you have the value of the slope of a straight line, there's also the value of one point that is located on the straight line, you can easily find out the equation of the straight line. So we find out the equation of this straight line with slope m2 that is 3 and with point A that is located on this straight line AB, according to the formula that I already presented to you. The formula of a straight line is as follows: y minus y1 equals to m times x minus x1. We're talking about the straight line AB. we have to find out the equation of the straight line AB. We already found out that the slope of this straight line AB is 3. So m equals to 3. And point A, this is point A, that is located on the straight line AB. So x1 equals to minus 6, that is the x-coordinate of point A. And the y-coordinate of point A is 2. So y1 equals to 2. So we have all the data that is needed in order to find out the equation of this straight line AB. You just have to put the data of this straight line AB inside this general formula for a straight line. In this way we find out the equation of this straight line AB. We do it now, we get that y minus y1. y1 is 2, so it is y minus 2 equals to m. m is 3, so it is 3 times x minus x1. x1 is minus 6. So in total we found out that y minus 2 equals to 3 times x minus 6. So y minus 2 equals to 3 times x minus 6 is plus 6. So in total we found out that y minus 2 equals to 3 times x plus 6. Here we open the brackets on this side of this equation and get that y minus 2 equals to 3 times x is 3x, and 3 times 6 is 18. So in total we found out that y minus 2 equals to 3x plus 18. Here we add 2 to this equation, and we get that y equals to 3x, 18 plus 2 is 20. So we found out that the equation of this straight line AB is equal to y equals to 3x plus 20. So write it down. The equation of this straight line AB is y equals to 3x plus 20. This is point B. Point B is a common point that belongs to both straight lines. Why? Because point B is definitely located on the straight line AB. Point B is definitely located on the straight line OB. And we have the rule that says that if a point is located on a straight line, then the point must satisfy the equation of the straight line. Okay, again, according to the rule that I mentioned, if a point is located on the straight line, then the point must satisfy the equation of the straight line. So point B is located on this straight line AB. The equation of the straight line AB is y equals to 3x plus 20. And according to the rule that I mentioned, if we substitute x by x1 and y by y1, the left side of the equation will be equal to the right side of the equation. So we do it now and get that this will be equation 1. y1 equals to 3x1 plus 20. And again, according to equation 1, y1 equals to 3x1 plus 20. Likewise, point B is also located on the straight line OB. Therefore, point B must satisfy the equation of the straight line OB. The equation of the straight line OB is y equals to 1/6. So we can substitute x by x1 and y by y1 because of the fact that the straight line B is located, point B is located on the straight line OB. So we do it now and get that y1 equals to minus x1. Okay. So here we have two equations for the value of y1. So in the next step we get equation 3 that says that y1 according to equation 1 must be equal to y1 according to equation 2. So y1 according to equation 1 equals to 3x plus 20, 3x1 plus 20 of course, and it must be equal to y1 according to equation 2. y1 according to equation 2 equals to minus x1. So the total according to equation 3, we actually found out that 3x plus 20 equals to minus x1. Here we will add x1 to this equation, equation 3. And get that according to equation 3, 3x1 plus x1 is 4x1. So 4x1 plus 20 equals to 0. Here we subtract 20 from this equation, equation 3. And get that according to equation 3, 4x1 equals to minus 20. Here we divide this equation, equation 3 by 4. And finally we get that 4x1 over 4 is x1. And it equals to minus 20 over 4 is minus 5. So in total we found out that the coordinate x of this point B, that is x1, is equal to minus 5. Repeat again, we found out that the coordinate x of this point B is x1 and x1 equals to minus 5. What is the coordinate y of point B? The coordinate y is y1. What is the value of y1? We have equation 2 according to equation 2. According to equation 2, y1 equals to minus x1. So y1 equals to minus x1. x1 is minus 5. So y1 equals to minus 5. Minus 5 is plus 5. So y1 equals to 5. Coordinate y of point B is y1 and y1 equals to 5. So in total, we actually found out that the coordinate B, the coordinate x of point B is minus 5 and the coordinate y of point B is 5. In the next step, I will present to you the formula of the distance between 2 points, and then we find out the distance between points A and B. We find out the distance between points A and O. So what is the formula for the distance between 2 points? In the drawing we have the right green triangle QPR. The distance between points Q and P is the length of the hypotenuse QP. Again, the distance between points Q and P is the length of the hypotenuse QP. So, because of the fact that this green triangle QPR is a right green triangle, we can implement the Pythagoras theorem on this green right triangle PQR. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. So, in this green right triangle QPR, QP squared, that is the square of the hypotenuse, equals to QR squared plus PR squared. Repeat again, this right green triangle QPR, PQ squared, that is the square of the hypotenuse, equals to PR squared plus QR squared. PQ is the missing hypotenuse, so it is PQ squared equals to PR squared. What is the length of PR? From the drawing it is very easy to see that PR equals to x2 minus x1. Again, PR equals to x2 minus x1. And again, PR equals to x2 minus x1, and therefore PR square equals to x2 minus x1 square. So in total, PR square equals to x2 minus x1 square. And we have plus QR square. What is the value of QR? From the drawing it is very easy to see that QR in total equals to y2 minus y1, therefore QR square must be equal to y2 minus y1 square. So in total we found out that pq square equals to x2 minus x1 square plus y2 minus y1 square. Here we'll take a root out of this equation and finally that pq equals to the square root of x2 minus x1 square plus y2 minus y1 square. Repeat again that PQ is the length of the hypotenuse QP, and PQ is also the distance between points Q and P. And because of the fact that points Q and P could be any points, this equation is the equation that gives us the distance between any 2 points. So we use the new formula in order to find out the distance between those 2 points B and A, and the distance between those 2 points A and O. Okay, so according to the formula that I presented to you, the distance between points A and B the coordinates of point A are 2 and minus 6. Likewise, the coordinates of point, this is point A, the coordinates of point B are minus 5 and 5. Our task is to find out the distance between points B and A. We define the coordinate x of point B is x2, and we define the coordinate y of point B is y2. So x2 equals to minus 5 and y2 equals to 5. Likewise, we define the coordinates of point A as x1 is the x coordinate, that is equals to 2, and we define the y coordinate of point A as y1, and y1 equals to minus 6. And the general formula for the distance between any 2 points is as follows. AB, that is the distance between points A and B. This is also the length of line 7, of course, equals to the square root of x2 minus x1 squared plus y2 minus y1 squared. So AB, this is the distance between points A and B, in total is equal to the square root of x2 minus x1. x2 is minus 5, minus x1, that is minus 6. So in the brackets we have minus 5 minus 6 squared plus y2 minus y1 squared. y2 is 5 minus y1, y1 is 2. Again, the coordinates of point A is x1 equals to minus 6, and y1 equals to 2. Okay, so y2 minus y1 squared equals to 5 minus 2 squared. So in total, we actually found out that AB, that is the distance between points A and B, is equals to the square root of minus 6 is plus 6, so inside the brackets we have minus 5 plus 6, that is 1, and 1 square is 1, plus 5 minus 2 is 3, and 3 square is 9. So inside the root we have 1 plus 9, that is 10. So we found out that AB, that is the length of line segment AB, and it is also the distance between points A and B. AB equals to the square root of 1 plus 9, that is 10. Again, AB, it is the length of line segment AB, and AB is also the distance between points A and B, and the distance between points A and B is square root of 10 units. Likewise, we find out the distance between points A and O according to the same formula. So the distance between points A and O is also the length of line segment AO. So the distance between points A and O, according to the new formula, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So this is the straight line AO. The coordinates of straight line AO is minus 6 and 2. The coordinates of point A are minus 6 and 2. We define the x coordinate that is minus 6 as x2, and we define the y coordinate of this point A as y2. So x2 equals to minus 6 and y2 equals to 2. Likewise, point O is the origin, and the coordinates of any origin is 0, 0. This is the starting point of both axes. Therefore, both axes are equal to 0. So we define the x coordinate of this point O, that is 0, as x1, and we define the y coordinate of point O as y1. So total we found out that x1 equals to 0, and y1 also equals to 0. And according to this formula that gives us the distance between 2 points, in this case this is the distance between points A and O. It's also the length of line segment AO. AO in total equals to the square root of x2 minus x1 squared. x2 is minus 6, minus x1 that is 0, so it is minus 6 squared, that is 36, plus y2 minus y1 squared. y2 is 2, minus y1 is 0, so 2 minus 0 is 2, and 2 squared is 4. So total y2 minus y1 squared equals to 4. So total we found out that inside the root we have AO equals to 36 plus 4 is 40. So in total we actually found out that AB, that is the distance between points A and B, and it is also the length of line segment AB, is equal to the square root of 10 units, and AO, that is the distance between points A and O, and it is also the length of straight line AO, is equal to the square root of 40 units in its length. Our task is to find out the area of this green shape. So what is the area of the green shape? The green shape is the right green triangle ABO. So our task is actually to find out the area of this green right triangle ABO. Again, because of the fact that the green shape is the green right triangle ABO, our task is to find out the area of the green right triangle ABO. We know that the area of any triangle equals to the base of the triangle times the height over 2. We choose the base of this green right triangle ABO as AB. And the height will be AO. Why the height is AO? Because the height AO creates 90 degrees with the base AB. So the height is AO divided by 2. We already found out that AB equals to the square root of 10 and AO equals to the square root of 40 divided by 2. The square root of 10 times the square root of 40 is the square root of 400 divided by 2. The square root of 400 is 20 and 20 over 2 is 10. So if we found out that the area of the green shape, that is the area that we are looking for this question, in total it is equal to the square root of, it is equal to 10 square units in its size, according to the first method. And again, I shall find out that the area of this green shape, that is the area that we're looking for this question, it is equal to 10 square units in its size. So we finished with the first method. In the next step I present to you how to find out the area of this green shape according to the second method. Those three squares are identical to each other. This side equals to 2, and therefore all the other sides must be also equal to 2, so they are identicals. When you find the origin, this point is point D. When you find this vertex as point C. When you find this point as point G. And when you find this point as point F. Note that all the angles of any square are right angles. So in this square, this is a right angle. This is also a right angle, this square, this is a right angle, and this is of course also a right angle. So in this big quadrilateral GFDC we have 1, 2, 3, 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be less a rectangle if not a square. So we write to the big quadrilateral QFDC as a rectangle because it has 4 right angles. So now the big quadrilateral GFCD is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are parallel to each other. Okay, the opposite sides of a rectangle are parallel to each other. So in the big rectangle GFDC, side GC parallel to the opposite side FD. And when you extend two parallel lines by straight line, the result also is parallel lines. Okay, so we extend those two parallel lines, FD and CG, by straight line. And again, the extended parallel lines must be also parallel to each other. Okay. In the next step, we will do a construction. In the next step, we will do a construction. That is to say, we will draw on this straight line perpendicular in such a way that it will pass for this vertex of this green triangle. And again, we will draw perpendicular at this straight line in such a way that the perpendicular will also pass for this vertex. And we join the perpendicular to this parallel line. So this angle equals to 90 degrees according to our construction. We define this point B. We define this point as point A. So by doing the construction, we get the big quadrilateral ABCD. Inside this big quadrilateral ABCD, we have 1, 2, 3 right angles. The sum of 3 right angles is 230 degrees. So 230 degrees plus the size of this 4th angle, total must be equal to 360 degrees, according to the rule that said that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this 4th angle must be equal to 9 degrees in size. So inside the quadrilateral ABCD, we have the big quadrilateral ABCD, we have 4 right angles, and therefore we can definitely relate to this quadrilateral ABCD as a right angle. So, as you know, the big quadrilateral ABCD is a right angle because it has 4 right angles. Another reason that this 4th angle in quadrilateral ABCD was equal to 90 degrees in size is because of the fact that we know that BC is parallel to AD. Yeah, BC is parallel to AD, and those two angles are defined as one-sided interangles. And we know that the sum of two one-sided interangles that are located between parallel lines is equal to 180 degrees. But this angle equals to 90 degrees, and therefore this missing angle must be equal to 90 degrees in its size. Okay, so we have two lengths that this missing angle must be equal to 90 degrees in its size. According to the rule that the sum of the angles in every quadrant is equal to 360 degrees, and we get the 270 degrees plus 90 degrees, the 360 degrees, and according to the rule that the sum of two one-sided interrogants that are located between parallel lines is equal to 180 degrees, and we get that this missing angle must be equal to 90 degrees plus 90 degrees, that is 180 degrees. That is the sum of one-sided interrogants that are located between two parallel lines. Okay, so, and we also know that the opposite sides of a rectangle are parallel to each other. So in the big rectangle ABCD, side CD must be equal to the opposite side AB, but CD in total is 2 plus 2 plus 2, that is 6. Therefore the opposite side AB must be also equal to 6 units in its length. So as you know, AB equals to 6 units in its length. In the next step, we define this angle, this is angle CGD as alpha. And we will focus BC is one side of rectangle ABCD. So BC is a side of a rectangle, it is absolute side line. So if we focus on the right side of the side line BC at point G, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 said that the sum of the angles on one side of a side line is equal to 180 degrees. So which angles we have at the right side of the side line BC at point G? And this angle is alpha plus this angle, it is a right angle according to what is given as the equation, that is associated is equal to 90 degrees in size, plus this missing angle is actually angle, we define this point as point F. This is angle FGB. This is the first missing angle, angle FGB. So in total, the sum of those three angles must be equal to 180 degrees according to rule 3. Repeat again. If we focus on the third line BC at point G, the sum of the angles, if we focus on the right side of the third line BC at point G, the sum of the angles must be equal to 180 degrees according to rule 3. So which angles we have the right side of the third line BC at point G, we have alpha plus 90 degrees plus the first missing angle, the angle FGB. In total, they must be equal to 180 degrees according to rule 3. So here we subtract alpha from this equation, or we subtract 90 degrees from this equation. And you will get that alpha plus the missing angle FGB is equal to 180 degrees minus 90 degrees is 90 degrees. Here we subtract alpha from this equation, and you get that the missing angle FGB is equal to 90 degrees minus alpha in its size. And again, this is the missing FGB, it is equal to 90 degrees minus alpha in its size. So it is now, this is equal to 90 degrees minus alpha in its size. So in this right side BFG, this angle equals to 90 degrees minus alpha. This angle equals to 90 degrees, and therefore this first missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, in this lower right triangle GCD, this angle equals to alpha, this angle equals to 90 degrees, and therefore this angle must be equal to 90 degrees minus alpha according to the sum rule that says that the sum of the angles in any triangle is equal to 180 degrees. It is very easy to see that those two right triangles are similar to each other according to angle similarity rule. So write the upper right triangle BFG is similar to the right lower triangle GCD. First of all, those two angles are both equal to alpha and therefore they are equal to each other. In addition, both those two angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees and therefore they are equal to each other. So she found out that all the figures of this upper right triangle BFG are corresponding equal to all the figures of this right lower triangle GCD. Therefore, those two right triangles are similar to each other according to angle similarity rule. So I write it down, and she found out that this is the green upper right triangle BFG. And it is similar. This is the sign of similar. So this right lower triangle GCD. And from the fact that those two right triangles are similar to each other, we will know that the following relationship exists between their sides. We derive that side GC of this green right triangle GCD over side BF of this upper right triangle BFG is equal to side CD of this right lower triangle GCD over side BG of this upper right triangle BFG. And again, from the fact that those two right triangles are similar to each other, we know that the following relationship exists between their sides. We will derive that side GC of the right lower triangle GCD over side BF of the right upper triangle BFG is equal to side CD of the right lower triangle GCD over side BF again equals to side CD of this lower triangle GCD over side BG of this right upper triangle BFG. And again, from the fact that those two right triangles are similar to each other, we know that the following relationship exists between their sides. We know that side GC of the right lower triangle GCD over side BF of the upper right triangle BFG is equal to side CD of the right lower triangle GCD over side GB of the right upper triangle BFG. GC equals to 2 according to what is given as the question, over BF. BF is the missing side, so we leave it as it is. And it is equals to CD. CD in total equals to 2 plus 2 plus 2, that is 6. Well, GB. GB is the missing side, so we leave it as it is. So in total, if you found out that two over BF equals to 6 over GB. Here we will first multiply this equation. And we get that 2 times GB equals to 6 times BF. Here we will divide this equation by 2. And finally we get that GB equals to 3 times BF. So if we define the length of side BF as x, then according to this equation, GB must be equal to 3x. GB must be equal to 3x. So sine BF equals to x, and therefore sine BG equals to 3x. We know that the diagonals of a square bisect the angle of the square again. The diagonals of a square bisect the angles of the square. So this is a square and this is the diagonal of this square. The diagonal of this square bisects this right angle into two halves. Each half must be equal to 45 degrees in size. So the first half is 45 degrees and the second half must be also equal to 45 degrees in its size. We know that the opposite sides of a rectangle are equal to each other. So we only found out that AB is equal to the opposite side CD. CD is 6, and therefore the opposite side AB must be also equal to 6 units in its length. Likewise, according to the sum rule, in the sum rectangle ABCD, side BC must be equal to the opposite side AB. So, written on. In the big rectangle ABCD, side BC must be equal to the opposite side AD. And again, this big rectangle ABCD side BC must be equal to the opposite side AD. But we already found out that BC in total equals to 3x plus 2. BC in total equals to 3x plus 2. And from this equation, 3x plus 2 equals to BC equals to AD. We will derive that AD must be also equal to 3x plus 2 units in its length. This is side AD, that equals to 3x plus 2 units in its length. Moving on, side AD in total is equal to 3x plus 2 units in its length. What is the length of this missing line segment? Line segment AF. From the drawing, it is very easy to see that FA in total equals to BA minus BF. And again, let me say 978 FA equals to BA minus BF. So let me see 978 FA equals to BA. BA is also of course AB. So AB equals to 6, so B8 is the same. This equals to 6 minus BF, that is X. So in total, we found out that F8, that is, let me see, 978 FA equals to 6 minus X units in its length. In this big right triangle DAF, this angle equals to 45 degrees. This angle equals to 9 degrees. 45 degrees plus 9 degrees, this is 135 degrees. So 135 degrees plus this third missing angle, total must be equal to 180 degrees, according to the rule that says that the sum of the angles in any triangle is equal to 180 degrees. And therefore this third missing angle must be equal to 45 degrees in its size. The next step, we will continue to focus on this big right triangle AFD. This big right triangle AFD, those two angles are equal to each other. Both of them equal to 45 degrees, therefore they are equal to each other. And we have the rule that says that in front of equal angles in the triangle, they are equal sides. So in front of those two equal angles in the big triangle DAF, we have those two sides that must be also equal to each other in their lengths. That's to say, side AF equals to side AD. AF equals to AD. AF or FA equals to AD. AF equals to AD. But we only found out that AF equals to 6 minus 6. So can I think that AF equals to 6 minus 6? And for this equation, 6 minus 6 equals to AF equals to AD. We derive that AD must be also equal to 6 minus X units in its length. We have already found out that from one side AD equals to 3x plus 2. But from the other side, AD also equals to 6 minus x. And from this equation, 6 minus x equals to AD equals to 3x plus 2. And we derive that 6 minus x equals to 3x plus 2. Those two sides of the equation are equal to each other. So we found out that 6 minus x equals to 3x plus 2. Here we add x to this equation and get that 3x plus x is 4x plus 2 equals to 6. Here we will subtract 2 from this equation. So 4x equals to 6 minus 2 is 4. So 4x equals to 4. Here we divide this equation by 4 and finally get that 4x over 4 is x equals to 4 over 4 is 1. So x equals to 1 unit in its length. That's then BF equals to x and x equals to 1. That is to say BF also equals to 1. Likewise, BG equals to 3x. X equals to 1, so 3x is 3 times 1, that is 3. So BG in total equals to 3 units in its length. In the next step, we will implement the Pythagoras theorem on this right upright triangle BFG. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the source of the perpendiculars. So in this upper right triangle BFG, here by PT is the abbreviation for Pythagoras theorem. So in this upper right triangle BFG, according to the Pythagoras theorem, fg squared, that is the square of the hypotenuse, equals to bf squared plus bg squared. And again, this upper right triangle BFG according to the Pythagoras theorem, fg squared, that is the square of the hypotenuse, equals to bf squared plus bg squared. Fg is the missing hypotenuse, so we limit it, so it is fg squared equals to bf squared. Bf is 1, therefore bf squared is 1 square, that is 1, plus bg squared. Bg is 3, therefore bg squared is 3 squared, that is 9. So total, we should have found out that fg squared equals to 1 plus 9, that is 10. So fg squared equals to 10. Here we take out all of this equation, and we get that the missing hypotenuse fg equal to the square of 10 units, the square root of 10 units in its length. This is the missing hypotenuse fg equal to the square of 10 units in its length. Write it down. Fg equals to the square root of 10 units in its length. Likewise, we implement the Pythagoras theorem on this right lower triangle GCD. This right lower triangle GCD. Here by PT is information from Pythagoras theorem. So in this right lower triangle GCD, GD squared, that is the square of the hypotenuse, equals to GC squared plus CD squared. And again, in this right lower triangle GCD, according to the Pythagoras theorem, GD squared, that is the square of the hypotenuse, equals to GC squared plus CD squared. GD is the missing hypotenuse, so we leave this it is, so it is GD squared equals to GC squared. GC is 2, therefore GC squared is 2 squared, it is 4, plus CD squared. CD in total is 6, therefore CD squared is 6 squared, it is 36. So in total, we actually found out that GD squared equals to 4 plus 36 is 40. So GD squared equals to 40. Here we take out all those equations and find that the missing hypotenuse GD is equal to the square root of 40 units in its length. This is the missing hypotenuse GD, is equal to the square root of 40 units in its length. Our task is to find out the area of this green shape. the green shape, it is actually the green right triangle FGD. So the task is to find out the area of this green right triangle FGD. Repeat again. Because of the fact that the green shape is the green right triangle FGD, our task is to find out the area of the green right triangle GFD or FGD. We know that the area of any triangle equals to the base of the triangle times the height over 2. We choose the base of this green triangle FGD SFG. And therefore, the height must be equal to GD because the GD creates an integral with the base GF. So the height is GD over 2. We have already found out that FG equals to the square root of 10 units in its length. Likewise, GD is equal to the square root of 40 units in its length, divided by 2. So in total, we found out that the area of the green shape, that is the area that we are looking for in this question, in total it is equal to the square root of 10 times the square root of 40 over 2. The square root of 10 times the square root of 40 is the square root of 400 over 2. The square root of 400 is 20 and 20 over 2 is 10. So, according to the second method, the area of the green shape, that is the area that we are looking for this question, is equal to 10 square units in its size. Repeat again, in both methods, we found out that the area of this green shape, that is the area that we are looking for this question, is equal to 10 square units in its size. So we finish with the second method. Next step of some of the lecture, that is to say, we repeat on the solution of the first method and then we repeat on the solution of this second method. In this question, our task is to find out the area of this green shape. The green shape is actually the green right triangle, so our task is to find out the area of this green right triangle. So, in the drawing, we have 3 identical squares. Those 3 squares are identical. Note that the side of one square is 2. So therefore, the side of all the other squares must be also equal to 2, of course. And again, our task is to find out the area of this green right triangle. This is actually the green shape is actually the area of this green right triangle. So again, because of the fact that those 3 squares are identical, and the side of this square is 2, therefore all this other side must be also equal to 2. Okay. In the next step, we defined the Cartesian system of this, we define the we created a contingent system on this in our drawing. Okay, so this is the x-axis and this is the y-axis, and the intersection point between the x-axis and y-axis is this point. This point is defined as the origin. That is to say, it is the starting points of both axes, the x-axis and the y-axis. Therefore, the coordinate x equals to 0 and the coordinate y of the origin O also equals to 0, but this is the starting point of both axes. And the intersection point between y-axis and x-axis actually they intersect with each other at a right angle. Therefore, this is a right angle, this is a right angle, this is a right angle, and also this is a right angle. Okay. And the definition of a slope is actually the slope of this straight line BO is equal to the tangent of the angle that this straight line creates with the positive x-axis. So the angle that BO creates with the positive x-axis is 45 degrees plus 9 degrees, that is 135 degrees. Why this angle equals to 45 degrees inside? Because of the fact that the diagonal of this square bisects this angle, so each one must be equal to 45 degrees. So 45 degrees plus 9 degrees is 135 degrees. Therefore, the slope of this straight line BO, the slope M, equals to tangent 135 degrees. Again, 185 degrees is the angle that the straight line BO creates with the positive x-axis. So the slope of the straight line BO equals to M, the slope M equals to 135 degrees, times 135 degrees is minus 1. And again, the slope of this straight line BO equals to minus 1. Therefore, the straight line BO descends from the left side to the right side because its slope is negative. Okay? And the point O, that is the origin, it is definitely located on the straight line BO. The coordinates of point O are 0 and 0. And if you have the value of one point of a straight line and also the slope of the straight line, you can easily find out the equation of the straight line according to the following formula. The equation of any straight line equals to y minus y1 times m, that is the slope of the straight line, times x minus x1. x1 and y1 is the coordinates of point O, that is the non-point of this is located on the straight line BO. So x1 equals to 0 and y1 also equals to 0. x1 equals to 0 and y1 also equals to 0. And we already found out that the slope of this straight line BO is equal to minus 1. So we can easily find out the equation of this straight line BO according to this formula, that y minus y1 equals to m times x minus x1. Just have to put the data of this straight line BO inside this general formula for a straight line. This way we find out the equation of this straight line BO. So actually we already done it, and we found out that y minus y1 is 0, so it is y minus 0 equals to m is minus 1 times x minus x1. x1 is 0, so it is x minus 0. Y minus 0 is y, and it is equals to x minus 0 is x. So it is 1 times minus x, so y equals to 1 times minus x. 1 times minus x is minus x. So in total, we found out that y equals to minus x. The equation of this straight line below is y equals to minus x. Likewise, we found out the slope of this straight line AO whenever we have 2 points that are located on the straight line and there are non-points. You can easily find out the slope of that specific straight line. Those 2 points are all located on the straight line AO, and therefore you can easily find out the slope of this straight line AO. Coordinate A equals to 1, 6 and 2. Why? Because of the fact that this is the positive x-axis and this is the negative x-axis. So from point O, we moved to the left to this point. So the distance between x coordinate of point A and the origin O is equals to minus 6, minus 0, this is minus 6. So the x coordinate of point A is minus 6. What about the y coordinate of point A? This is one side of this square is equals to 2. Therefore, this point is 2. So the y coordinate of point A is 2. So in total, the coordinates of point A are minus 6 and 2. Likewise, the coordinate of the origin O, that is the starting point of both axes, is 0, 0. So actually, so this is the straight line AO. I copy the straight line AO here. This is the straight line AO that is coming from the original drawing. The coordinates of point A are minus 6 and 2. We define minus 6 as x2, that is the x coordinate, and we define the y coordinate as 2. So y2 equals to 2. Likewise, define the coordinate O, that is the origin. The coordinate of point O is 0, 0, of course. So define the x coordinate as x1, and the y coordinate of this origin O as y1. And the slope of any straight line equals to the vertical difference over the horizontal difference. That is to say, it is y2 minus y1 over x2 minus x1. y2 is 2, minus y1 is 0. So it is 2 minus 0, that is 2 over x2 minus x1. x2 equals to minus 6 minus x1, x1 equals to 0. And minus 6 minus 0 is minus 6. So in total, m equals to 2 over minus 6. Here we divided both the numerator and the denominator of this number by 2. 2 over 2 is 1, and minus 6 over 2 is minus 3. So in total, we found out that the slope of the straight line AO equals to minus third. You can see that the straight line AO descends from the left side to the right side. You can see in the original drawing that the straight line AO descends from the left side to the right side, or it falls from the left side to the right side because of the fact that the value of the slope is negative, therefore it falls from the left side to the right side. Exactly as I explained at the beginning of the lecture. So we have the slope of this straight line AO equals to minus third, negative third. So here we can implement rule 12. Why? Because of the fact that the straight line BA is perpendicular to the straight line AO. That is to say, at the intersection point of those two straight lines, they create a right angle. And when two straight lines create a right angle between them, you can implement rule 12. So repeat quickly on rule 12. According to rule 12, if two lines intersect with each other at 90 degrees, that is to say, they create a right angle in the intersection point, and we know that the slope of the first line is M1, the slope of this first line is M1, and the slope of the second line, the slope of this second line is M2. Then the following equation is 2. That is M1 times M2 equals to minus 1. That is to say, the product of their slopes equals to minus 1. The products of their slopes equals to negative 1. So according to rule 12, if two straight lines intersect with each other at a right angle, at the intersection point at a right angle, then the product of their slopes equals to negative 1. You can definitely implement rule 12 in our drawing. Why? Because in our drawing, the straight line AB intersects with the straight line AO at a right angle, because this is a right angle. Therefore, you can implement a rule 12. We already found out that the slope of this straight line AO equals to minus third. The slope of this straight line AB is unknown, so we define the slope as M2. And according to rule 12, because of the fact that those two straight lines intersect between them at a right angle, then the product of their slopes must be equal to minus 1, or negative 1. That is to say, M2 times minus third equals to minus 1 according to rule 12. So again, according to rule 12, M2 times minus third equals to minus 1. Here we multiplied this equation by minus 1. Minus times minus is plus, so here we have M2 over 3, and minus 1 times minus 1 is 1. So in total, we found out that M2 over 3 equals to 1. Here we multiplied this equation by 3 and found out that M2 equals to 3. That is to say, the slope of this straight line AB is equals to 3. You can see that the straight line AB rises from the left side to the right side. Okay? Why? Because of the fact that its slope is positive, therefore it rises from the left side to the right side. Exactly as I explained in the beginning of the lecture. So this is point B. Point B is a common point that belongs to both straight lines. Point B is definitely located on the straight line AB, and point B is definitely located on the straight line OB. And we have the rule that says if a point is located on a straight line, then it must satisfy the equation of the straight line. Again, if a point is located on the straight line, then it must satisfy the equation of the straight line. Point B is located on the straight line AB, therefore point B must satisfy its equation. This is y equals to 3x plus 20. What is the meaning that the point must satisfy the equation? It means that if you substitute x by x1, and we substitute y by 1, we get that y1 equals to 3x1 plus 20, y1 equals to 3x1 plus 20, and the left side of the equation will be equal to the right side of the equation. So, but first of all, we have to find out the equation of the straight line AB. We know that the slope of this straight line AB equals to 3. It is a positive slope. And point A is definitely located on the straight line AB, and therefore we can easily find out the equation of this straight line AB according to the formula that I have already presented to you. The formula of any straight line equals to y minus 1 equals to m times x minus x1. The slope m of this straight line AB is 3, so m equals to 3. The coordinate x of point A is minus 6, and the coordinate y of point A is 2. So x1 equals to minus 6 and y1 equals to 2. We have all the data that is needed in order to find out the equation of this straight line AB. We just have to put the data of the straight line AB inside this equation. And this way we find out the equation of the straight line AB. So according to this equation, y minus y1. y1 is 2, so it is y minus 2 equals to m is 3. Inside the brackets we have x minus x1. So it is x minus x1. x1 is minus 6, so it is x minus 6. X minus 6 is x plus 6. So to that we actually found out that y minus 2 equals to 3 times x plus 6. Here we open the brackets on this side of the equation, and finally found out that y minus 2 equals to 3 times x is 3x, and 3 times 6 is 18. So to that we actually found out that y minus 2 equals to 3x plus 18. Here we added 2 to this equation, and we found out that y equals to 3x plus 12 and 18 over 2 is 20. So in total, the equation of this straight line AB is y equals to 3x plus 20. Again, the equation of this straight line AB is y equals to 3x plus 20. As I already mentioned before, point B is definitely located on the straight line AB, and point B is definitely located on the straight line OB. And as I already mentioned before, if a point is located on a straight line, then it must satisfy the equation of the straight line. Point B is located on the straight line AB, therefore point B must satisfy its equation, that is to say, it must satisfy the equation of y equals to 3x plus 20. That is to say, if we substitute y by y1 and x by x1, we get that the left side of the equation equals to the right side of the equation. So we did it, and we should find out that y1 equals to 3x1 plus 20. Moving to equation 1, y1 equals to 3x1, y1 equals to 3x1 plus 20. Likewise, point B is located also on the straight line OB, therefore it must satisfy the equation of the straight line OB. The equation of the straight line OB is y equals to minus x. So if we substitute y by y1 and x by x1, the left side of the equation will equal to the right side of the equation. So we got that y1 equals to minus x1. So according to equation 2, y1 equals to minus x1. So we have two equations for y1. Therefore, we created equation 3 that said that y1 according to equation 1 must be equal to y1 according to equation 2. y1 according to equation 1 equals to 3x plus 20. It must be equal to y1 according to equation 2. y1 according to equation 2 equals to minus x1. So in total, we actually found out that according to equation 3, 3x1 plus 20 equals to minus x1. Here we added x1 to this equation 3, and we found out that 4x1 plus x1 is 4x1 plus 20 equals to 0. Here we subtracted 20 from this equation 3, and we found out that according to this equation 3, 4x1 equals to minus 20. Here we divided this equation 3 by 4, and we found out that 4x1 over 4 is x1, and this equals to minus 20 over 4 is minus 5. So in total, we found out that x1 equals to minus 5. That is to say, the coordinate x of this point B, this is x1, is equal to minus 5. What about the coordinate y point B? This is y1. According to equation 2, y1 equals to minus x1. So y1 equals to minus x1. So this minus x1 and x1 is minus 5. So if you found out that y1 equals to minus 5, this is plus 5. So y1 equals to 5 units in its length. y1, the coordinate y of this point B, that is y1 equals to 5. So total, the coordinate B, the coordinates of point B are minus 5 and 5. In the next step, I presented to you the formula of the distance between 2 points, and then use the new formula in order to find out the distance between points B and A and the distance between points A and O. So, what is the distance between those 2 points, Q and P? Because of the fact that Q and P could be any points, the formula will give us the distance between any 2 points. So, in the drawing we have the right green triangle PQR. And therefore, whenever you have a right triangle, you can implement the Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this green right triangle PQR, QP square, or PQ square, that is the square of the hypotenuse, equals to QR square plus PR square. And again, according to the Pythagoras theorem, in this green right triangle PQR, PQ square, that is the square of the hypotenuse, equals to PR square plus QR square. PQ is the missing hypotenuse, so leave it as it is. I repeat again that the distance between points Q and P is also the length of the hypotenuse QP. Again, the distance between points Q and P is also the length of the hypotenuse PQ. So PQ squared, that is the square of the hypotenuse, equals to PR squared. What is the length of PR? PR equals to y2 minus y1, and therefore again, PR, this is PR. PR equals to x2 minus x1. Therefore, PR square equals to x2 minus x1 square. Again, PR square equals to x2 minus x1 square. Plus Q R square. What is the length of QR? QR equals to y2 minus y1, and therefore QR square must be equal to y2 minus y1 square. So total we found out that PQ square equals to x2 minus x1 plus y2 minus y1, PR square equals to x2 plus x, PQ square equals to x2 minus x1 square plus y2 minus y1 square. Here we took out of this equation and found out that PQ, again PQ is the distance between points P and Q, and PQ is also the length of the hypotenuse QP. So PQ equals to the square root of x2 minus x1 square plus y2 minus y1 square. So we can use the new formula in order to find out the distance between those 2 points A and B. The coordinates of point B are minus 5 and 5. The coordinates of point A are minus 6 and 2. Minus 6 and 2. So we define the x coordinate of point B as x2, and we define the y coordinate of point B is equals to 5 as y2. Likewise, we define the x coordinate of point A that is equals to minus 6 as x1, and define the y coordinate of this point A is equals to 2 as y1. And we use the new formula in order to find out the distance between points A and B. The distance between points A and B is also the left of line segment AB. So the new formula, according to the formula, the distance between points A and B, this is also the left of line segment AB, equals to the square root of x2 minus x1 square plus y2 minus y1 square. So AB equals to the square root of x2 minus x1. x2 equals to minus 5 minus x1, that is minus 6. So this minus 5 minus 6. Minus 5 minus 6 is minus 5 plus 6, and minus 5 plus 6 is 1, and 1 square is 1. So in total this expression equals to 1, and we have plus y2 minus y1 square. y2 is 5 minus y1 is 2. 5 minus 2 is 3, and 3 square is 9. So in total inside the root we have 1 plus 9, that is 10. So AB equals to the square root of 10 units in itself. I repeat again that AB is the length of line segment AB, and AB is also the distance between points B and A. Likewise, according to the new formula, we found out the distance between those 2 points A and O. The distance between points A and O is also the length of line segment AO. Repeat again, the distance between points A and O is also the length of line of side AO. Of this triangle AOB. I copy the side line AO, and then you print here the coordinates of point A are minus 6 and 2. We define the coordinate x as x1, and the coordinate y of point A. We define the coordinate x of point A as x2, and define the coordinate y of we define the coordinate y of point A, that is 2, as y2. This is point O, the coordinates of point O, that is the origin, are 0 and 0. Define the coordinate x of this point A is x1, define the coordinate y of this point O as y1. So according to the new formula, the distance between points A and O, that is also the length of line segment AO, is equals to the square root of x2 minus x1 square plus y2 minus y1 square. Okay? So we have x2 minus x1 square. x2 is minus 6, minus x1 is 0. Minus 6 minus 0 is minus 6, and minus 6 square is 36. Plus y2 minus y1 square. y2 equals to 2, minus y1, that is 0. 2 minus 1 is 2, and 2 square is 4. So in total, y2 minus y1 square equals to 2 square, that is 4. So in total, inside the root we have 36 plus 4, that is 40. So in total, we should find out that the length of line segment AO, that is also the distance between points A and O, is equals to the square root of 40 units in its length. Repeat again. We found out actually that the length of line segment AB, that is also the distance between points A and B, is equal to the square root of 10 units in itself. Likewise, the distance between points A and O, that is also the length of side AO of the green right triangle AOB, is equal to the square root of 40. And our task is to find out the area of this green right triangle AOB. The green shape, the green shape is actually the green right triangle AOB, so our task is to find out the area of the green right triangle AOB. We know that the area of any triangle equals to the base of the triangle times the height over 2. We choose the base of this green right triangle AOB as AB, and the height is AO. Yeah. The base is AB, and the height is AO. Divided by 2. AO is square root of 10, AB is square root of 10, AO is square root of 40 over 2. Square root of 10 times square root of 40 is square root of 400 over 2. The square root of 400 is 20, and 20 over 2 is 10. So in both methods, we actually found out that the area that we are looking for this question, that is the area of this green shape, is equal to 10 square units in its size. Okay, so we finish with the first method. The next time I'll read on the solution according to the second method. So we have here three identical squares. The length of one side is 2, therefore the length of all the other sides of all the squares must be also equal to 2. And this is square, therefore this angle is a right angle. This also it is a right angle. In this square, this is a right angle, and this is also a right angle. So in the big quadrilateral GFDC, we have 1, 2, 3, 4 right angles, and according to Rule 5, any quadrilateral that has 4 right angles must be this rectangle in front of the square. So we relate to the big quadrilateral GFDC as a rectangle because it has 4 right angles. So quadrilateral GFCD is a rectangle. But we also know that the opposite sides of a rectangle are parallel to each other. So in the big rectangle GFDC, side CG is parallel to side DC. According to the rule that says that the opposite sides of a rectangle are parallel to each other. So in the next step, we extended both those two parallel sides by a side line, and we extend two parallel lines by a side line. The result will be also two parallel lines. Yeah, we extend two parallel lines by a side line. The result that is the extended line segment must be also parallel to each other. So CB is parallel to DA. In the next step, we did a construction, that is to say, we drew perpendicular on BC and this point B in such a way that it will pass for this vertex F of the green right triangle FGD. Again, we do perpendicular at this side in such a way that the perpendicular will pass for the vertex F of the green triangle FGD. So this angle equals to 90 degrees according to our construction. So in total in the big quadrilateral ABCD, we have 1, 2, 300 degrees. The sum of 300 degrees is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees inside. So inside the big quadrilateral we have 4 angles. Therefore quadrilateral ABCD is a rectangle according to Rule 5. Another reason that this fourth missing angle must be equal to 90 degrees inside is according to the rule that the sum of two one-sided triangles that are located between parallel lines is equal to 180 degrees. CB is parallel to DA. This is a right angle. Those triangles are defined as one-sided triangles and are located between the parallel lines CB and DA. And therefore, the sum of those triangles must be equal to 180 degrees according to the rule that I mentioned. So 90 degrees plus the size of this missing angle in total must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. So I presented two reasons that this fourth missing angle must be equal to 90 degrees in its size. So because of the fact that in quadrilateral ABCD we have 4 angles, we can relate to quadrilateral ABCD as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in the big rectangle ABCD, side DC must be equal to the opposite side AB. But DC in total is 2 plus 2 plus 2, that is 6. And therefore the opposite side AB must be also equal to 6 units in its length. In the next step we define this angle CGD is alpha. BC is one side of the big rectangle ABCD, therefore BC it is absolutely a straight line. Again, BC is one side of the rectangle, it is absolutely a straight line. So if you focus on the right side of the straight line BC at point G, the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the right side of the straight line BC at point G? We have this angle that is alpha, plus this angle that is 90 degrees according to what is given as a equation, plus this missing angle that is the angle FGB. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Repeat again. If you focus on the right side of the straight line BC at point G, the sum of the angles must be equal to 180 degrees according to rule 3. So which angles we have at the right side of the straight line BC at point G, we have alpha plus 90 degrees plus the first missing angle, the circular angle FGB. In total must be equal to 180 degrees according to rule 3. Here we subtracted 90 degrees from this equation, and finally found out that alpha plus the missing angle FGB must be equal to 180 degrees minus 90 degrees, it is 90 degrees. Here we subtracted alpha from this equation, and finally found out that the missing angle FGB equals to 90 degrees minus alpha in its size. Again, this is the missing angle FGB, is equals to 90 degrees minus alpha in its size. So in this right triangle GBF, this angle equals to 90 degrees minus alpha. This angle equals to 90 degrees, and therefore this first missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, in this right lower triangle GCD, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. According to the sum, it says that the sum of the angles in any triangle is equal to 180 degrees. In the next step, we prove that those two right triangles are similar to each other according to angle similarity rule. So why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. So we should found out that all the angles in this upper right triangle BFG are corresponding equal to all the angles of this right lower triangle GCD, and therefore those two right triangles are similar to each other according to angle similarity rule. But again, we should find out that the upper right triangle BFG is similar. This is the sign of similar to the right lower triangle GCD according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that side GC of this right lower triangle GCD over side BF of this upper right triangle BFG is equal to side CD of this right lower triangle GCD or side GB of this upper right triangle GBF. With again, from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We derive that side GC of the right lower triangle GCD over side BF of the upper right triangle BFG equals to side CD of the right lower triangle GCD or side GB of the right upper triangle BFG. GC is 2 over FB. FB is the missing sign, so leave it as it is. And this equals to CD. CD in total equals to 2 plus 2 plus 2, that is 6, over BG. BG is the missing side, so we leave it as it is. So in total, we actually found out that 2 over BF equals to 6 over GB. Here we cross multiply this equation and finally found out that 2 times GB equals to 6 times BF. Here we divided this equation by 2 and finally found out that 2 times GB over 2 is GB and is equals to 6 times BF over 2, that is 3 times FB. So in total we found out that GB equals to 3 times BF. So if we define the length of side BF as x, then according to this equation, GB will be equal to 3x. So if BF equals to x, then GB must be equal to 3x. So again, define this side BF as x, and therefore GB must be equal to 3x. Okay. So in the big rectangle ABCD, side AB equals to side CD. CD is 6, therefore AB must be also equal to 6. AB equals to 6. Likewise, according to the sum rule, in the same big rectangle ABCD, side BC must be equal to double side AD. But BC in total is 3x plus 2, therefore double side AD must be also equal to 3x plus 2 in its length. Repeat again. So AD must be also equal to 3x plus 2 in its length. We know that this diagonal bisects this area because it is a square. So each half must be equal to 45 degrees in size. So this half, the first half equals to 45 degrees, and the second half equals also to 45 degrees in size. So in this big triangle FAD, this angle equals to 45 degrees inside, this angle equals to 9 degrees, and therefore 45 degrees plus 9 degrees, it is 135 degrees. Therefore, this furthest area must be equal to 45 degrees in its size. Why? Because 135 degrees plus 45 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. So this furthest area must be equal to 45 degrees in size. What is the length of this missing line segment? AF. AF equals to AB plus FB. Again, AF or FA equals to BA plus BF. Again, FA equals to BA plus BF. So FA, this missing line segment equals to BA. BA is 6 plus BF. BF is x. So in total, FA, this missing line segment, FA equals to 6 plus x units in its length. We have the rule that says that in front of equal angles in the triangle, there are equal sides. So in this big right triangle FAD, in front of those two equal angles, we have those two sides that must be also equal to each other of the lengths. That is to say, FA equals to AD. Then, according to the rule that I mentioned, AF equals to AD. According to the rule that says that in front of equal angles in the triangle, there are equal sides. But we have already just right now found out that FA equals to 6 minus x. So you can write here that FA equals to 6 minus x. And from this equation, 6 minus x equals to AF equals to AD. We know that the missing side AD must be also equal to 6 minus x units in its length. AD equals to 6 minus x units in its length. So from one side, we found out that AD equals to 3x plus 2. But from the other side, we just right now found out that AD equals to 6 minus x. And from this equation, 6 minus x equals to AD equals to 3x plus 2. We will derive that those two sides of the equation are equal to each other. That is to say, 6 minus x equals to 3x plus 2. Here we add x to this equation, and finally found out that 3x plus x is 4x. So 4x plus 2 equals to 6. Here we subtract the 2 from this equation, and finally found out that 4x equals to 6 minus 2 is 4. So 4x equals to 4. Here we divide this equation by 4, and finally found out that x equals to x over 4 is x, so x equals to 4 over 4, that is 1. Side BF equals to x and x equals to 1, therefore BF equals to 1 units, side BF equals to 1 units length. Likewise, BG equals to 3x, but x is 1, therefore BG equals to 3 times 1, that is 3. So the length of side B equals to 3, and the length of side BF equals to 1. The next step, we implement the Pythagoras theorem on this upper right triangle, triangle BFG. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the source of the perpendicular. So in this right triangle BFG, FG squared, that is the square of the hypotenuse, equals to BF squared plus BG squared. Repeat again, according to the Pythagoras theorem, in this right triangle BFG, BF squared, it is actually GF squared or FG squared, it doesn't matter. So FG squared, that is the square of the hypotenuse, equals to BF squared plus BG squared. FG is the missing hypotenuse, so we have to see this, so it is FG squared equals to BF squared. BF is 1, therefore BF squared is 1 squared, that is 1, plus BG squared. BG is 3, therefore BG squared is 3 squared, that is 9. So in total, we actually found out that FG squared equals to 1 plus 9. And again, in total, we found out that FG squared, the square of the hypotenuse, equals to 1 plus 9. 1 plus 9 is 10, so FG squared equals to 10. Here we took out of the equation and finally found out that the missing hypotenuse FG equals to the square root of 10 units in its length. This is the hypotenuse FG, that equals to the square root of 10 units in its length. Likewise, we implemented the Pythagoras theorem on this right lower triangle, triangle GCD. This right lower triangle GCD, GD squared, that is the square of the hypotenuse, equals to GC squared plus CD squared. And again, this right triangle GCD, according to the Pythagoras theorem, GD squared, that is the square of the hypotenuse, equals to GC squared plus CD squared. So GD is the missing hypotenuse, so whatever this it is, so it is GD squared equals to GC squared. GC is 2, therefore GC squared is 2 squared, that is 4, plus CD squared. CD in total is 6, and therefore CD squared is 6 squared, that is 36. So in total, we actually found out that GD squared equals to 4 plus 36, that is 40. So GD squared equals to 40. Here we took out of this equation and I found out that the missing hypotenuse GD equals to the square root of 40 units in its length. This is the hypotenuse GD, that equals to the square root of 40 units in its length. We found out that FG equals to the square root of 10 units in its length. Repeat again. Again, FG equals to the square root of 10 units in its length, and GD equals to the square root of 40 units in its length. Our task is to find out the area of this ring shape. The area of the ring shape is actually the area of this ring right triangle FGD. Because of the fact that the ring shape is the ring right triangle FGD, our task is actually to find out the area of the ring right triangle FGD. We know that the area of any triangle equals to the base of the triangle times the height over 2. We choose the base as FG and the height is GD. Why the height is GD? Because it gets 90 degrees with the base GF. So the base is FG, the height is GD over 2. We only found out that FG equals to the square root of 10, GD equals to the square root of 40 over 2. The square root of 10 times the square root of 40 is 400, is the square root of 400 over 2. The square root of 400 is 20, and 20 over 2 is 10. So in both methods, we actually found out that the area that we are looking for this question, that is the area of this ring shape, is equal to 10 square units inside. Okay, thank you very much.